And using an IDE such as PyCharm, Spider, VS Code, string variables. Every variable holds a value, which is the information assigned and associated with that variable. You can change the value of a variable in your program at any time. So strings. A string is simply a series of characters. Anything inside quotes is considered a string in Python, and you can use single or double quotes around your strings like this. So this is a string inside double quotes, and this is also a string inside single quotes, but there are also double quotes inside the single quotes. So this is a string message, and we can print this string. Hello Python world, and this is also a string. We can also print and changing case in a string with methods. So this is a string with all lowercase alphabet. Then you can print name dot title. So each word begins with a capital letter. Name is a string. If we show all alphabets are lowercase, then we can print this string but with the title method after this string. So A, Ada, Lovelace. So these two alphabets will be uppercase. Can also print a name dot up. So all alphabets will be uppercase. Or name dot lower, then all alphabets will be lowercase. So we create string name again. We show name as title case. So we can print with uppercase. All alphabets are uppercase now. And now all alphabets are lowercase. Combining or concatenating strings. So this is a string first name, and this is a string for last name. So you can create a string called full name using first name plus a space symbol and with last name. Then you can print out. So first name Ada, last name is Lovelace. Then full name is addition. So is the string concatenation of first name and last name and with a space. Then can print out his full name Ada space Lovelace. Adding white space to strings with tabs or new lines. So space tabs and end of line symbols are called white spaces. So you can print \t means tab, add a tab space before text. Then you can print also with \n new line, \n with new line. And you can combine \n and \t. So this is for the concatenation. Now we can print Python, then print \t Python. So there are tab space. Also print with a new line. The language Python, C, JavaScript. Can also print with newline and a tab space. Newline and a tab space. Stripping white spaces. So favorite language is Python with a space. Then favorite language R strip will right side white space removed temporarily. And favorite language L strip will remove white space at the left side. Favorite language dot strip will remove white space at both sides. So favorite language Python, the space, and can print out. You see a space here. And if we use R strip, then no space here now. But fifth language has not been changed, so R strip is temporarily remove this space. So to remove the white space from the string permanently, you have to store the stripped value back into the variable. So this is favorite language with a string after this, with a space after this string. You can use R strip but assign back to this string variable. So create again favorite language with a string the right side, then we R strip this space and assign back to this variable. Then we show this favorite language again. Now string has been removed permanently. You can add, subtract, multiply, and divide numbers in Python. And 3 double star double asterisk 2 means exponents. So 3 square. And 10% symbol 3 means modulo. So returns the remainder of division. 3 exponent 2 9 age 23 and avoiding type errors with the str function. So age is 23. Next, if we create a string variable called message equals happy plus age plus at birthday, then it will have error because Python not allowed you to add numeric variable with string directly, so you have to transform this numeric variable to the type string before adding together. So now message happy plus strh and plus best birthday. Then we can print a message happy 23rd birthday. A list is a collection of items in a particular order. In Python, square brackets indicate a list, and individual elements in the list are separated by commas. So we can create a list called bicycles with 4 different types as the elements of this list. So we create another list called number list with 5 numbers in the brackets. So this is a string type list, and this is a numeric list. Create a list. If we show this list, and create a bicycle list. You can print out this bicycle list for bicycles, and accessing elements in a list. You can access any element in a list by telling Python the position or index of the item desired. For example, we can print the first bicycle in this list. And you can also use the string method on any element in a list. So we can get the title form of the first bicycle. You can print first bicycle in the list. Select. Can also print first bicycle's title form in the list. The T is capitalized. And note that index in the list starts at 0, not 1. And Python considers the first item in a list to be at a position 0, not position 1. The second item in a list has an index of 1. So if we print bicycle bracket 1, then the second item will be pulled out. And if we write print bicycles 3 in the bracket, then the fourth item will be get out. So we can print the second bicycle and print the fourth bicycle. And we can also access items from the end side. So -1 means the last item in a list. -2, the second item from the end of the list, and so on. So we can print the last bicycle. We also print the second item from the end of the list. Using individual values from a list, you can use individual values from a list just as you would any other variable. For example, you can use concatenation to create a message based on a value from a list. So for example, we can get out the first bicycle and using its title form, then this item concatenated with this string and this string. We create a message with concatenation of string and the bicycle's first element with the title form and plus symbol. Then we print out this message. So this message is my first bicycle with a check. Most lists you create will be dynamic, meaning you will build a list and then add and remove elements from it as your program runs its course. To change an element, use the name of the list followed by the index of the element you want to change, and then provide the new value you want that item to have. For example, this is original list with 4 car brands, and we can change the first element of this list to another value. So this is a list with 4 cars. Print. Then we can set the first value to Ducati, and we print again. Now the first value has been changed. And we can also add elements to a list. Python provides several ways to add new data to existing lists. We can append elements to the end of a list. So this is the original list for the motorcycle. And we can use append function So motorcycle dot append Ducati. So the Ducati is added to the end of the list. Create this list with 3 motorcycles. 3 motorcycles now. Then we can append Ducati to the end of the list. So now the list has 4 cars now, with Ducati at the last position. You can start with an empty list and then add items to the list using a series of append statements. So we can also create an empty list first with 2 brackets. Then motorcycles append Honda, append Yamaha, and append Suzuki. Create first an empty list. Then we can append 3 motorcycles. We show this list again. So now the list motorcycle has 3 cars now. And you can also insert elements into a list. So you can add a new element at any position in a list by using the insert method. You do this by specifying the index of the new element and the value of the new item. So this is a list, and we can insert the first position, a new motorcycle here. So this is a list with 3 motorcycles. Can insert Ducati to the position 0, first position, and we show this motorcycle. Now Ducati is the first motorcycle and the other 3 motorcycles from the original list. And we can also remove elements from a list. You can remove an item according to its position in the list or according to its value. So removing an item according to its position, you can use the del statement if you know the position of the item you want to remove from a list. So this is a list with 3 motorcycles. We can remove the first motorcycle, the second item, the list with 3 motorcycles. 3 motorcycles now. Then we'll del first motorcycle. Show again. Now only the 2 motorcycles left in the list. Can also create 3 motorcycles now. The motorcycle has 3 motorcycles in the list now. We can delete the second motorcycle this time. We show again this list. Only 2 left. A second Yamaha has been removed. You can use pop method to remove an item. Sometimes you will want to use the value of an item after you have removed it from a list. So the pop method removes the last item in a list, but it lets you work with that item after removing it. So this is a list with 3 motorcycles. So we can use pop method to remove the last one of this list. Then put this removed item in this object. So we can print this object later. So this is a list with 3 motorcycles. Then we can use the pop method. Remove the last one of this motorcycle list. Then print again this motorcycles list. Now 2 left. The last one, Suzuki, has been removed. And we can also print this popped motorcycle. Suzuki, that's correct. And popping items from any position in a list. You can actually use pop to remove an item in a list at any position by including the index of the item you want to remove in parentheses. So this is the list with 3 motorcycles. So we can pop 0. So the first item is removed from the original list and stored in variable called first owned. Create this motorcycle list again. So we pop the first one. Then we can print the first motorcycle I owned was is the title. This message is the string concatenated with this popped value with a title form. So when you want to remove from a list, if you know the value of the item you want to remove, you can use the remove method. So this is a list with 4 motorcycles. So if we want to remove the item with this value, so we can use motorcycle.remove Ducati. So Ducati is removed, but note the remove method deletes only the first occurrence of the value you specify. So if there is a possibility the value appears more than once in the list, you will need to use a loop to determine if all occurrences of the value have been removed. So this is a motorcycle list with 4 motorcycles. Then we can remove Ducati using remove function. Then print again. Now Ducati has been removed. Sometimes you will want to preserve the original order of your list, and other times you will want to change the order. Python provides a number of different ways to organize your lists depending on the situation. Sorting a list permanently with the sort method. So this is a list with 4 cars, and you can use cars.sort. Then the order of the elements are sorted in the list. So we create a list. So the order of the elements in the cars, like now, you can use sort. We'll print again. So now the elements are sorted alphabetically in the list. And you can also sort this list in reverse alphabetical order by passing the argument reverse equals true to the sort method. So you can use sort reverse true. This is a car list with 4 motorcycles. You can sort reverse true. Then print again. So now the elements in the list has been sorted alphabetically with reverse order. So sorting a list temporarily with the sorted function. The sorted function lets you display your list in a particular order but doesn't affect the actual order of the list. So this is a list of 4 motorcycles. You can use sorted cars. So it will show the list in a sorted order. But if you print this car again, the order has not been sorted. It has the original order. We'll create again this list for the motorcycle. So this is the original order. Copy again. So here is the original list. Print with the sorted function. So this is the sorted list alphabetically. Okay, again print Here is the original list again. We'll choose. So the original order in the list has not been changed. We can also print the sorted cars in the reverse order. So this is the reverse alphabetical list if we use sorted. So print a list in reverse order. So just to reverse the original order of a list, this may not be the alphabetical order. So just to reverse the original order of the list, you can use a reverse method. So this is the original list. If we use cast reverse and print a cast, then the order of the elements are reversed. So the last one will be printed first. So the reverse method changes the order of a list permanently, but you can revert to the original order anytime by applying reverse to the same list a second time. So we print. This is the. Okay, we create again this motorcycle list. This is the original order, and we use cars dot reverse. Then print again. Then order of elements are reversed in the list. Okay, finding the length of a list. You can quickly find the length of a list by using the len function. So we can use len cars and it will return the number 4. So note that Python counts the items in a list starting with 1, not from 0. So this is the list for cars with 4 elements. We use len cars. It will be 4. Looping allows you to take the same action or set of actions with every item in a list. So when you want to do the same action with every item in a list, you can use Python's for loop. Let's say we have a list of magicians' names, and we want to print out each name in the list. A for loop will let Python to handle this task easily. So in the for loop, Python pulls a name from the list magicians and store it in the variable magician. Then print the name that was just stored in magician. Python then repeats this operation for each name in the list. So this is a list of magician with 3 magicians. Then we can write 4 magician in magicians. So magicians is a list. In the for loop, for magician will take each element from the magicians, then store in this variable called magician. Then inside the for loop, we print each magician until there's no magician left in this list. So where the no more values are in the list, Python moves on to the next line in the program after the for loop. So this is the for loop. We create a list called magicians with 3 magicians. Then we can write 4 magician, print magician. So each magician has been printed out. It is helpful to choose a meaningful name that represents a single item from the list. For example, here is a good way to start a for loop for a list of cats, a list of dogs, and a general list of items. We can write, for example, for cat in cats, for dog in dogs, or for item in list of items. And using singular and plural names can help you identify whether a section of code is working with a single element from the list or entire lists. Doing more work within a for loop. So every indented line following the line for magician in magicians is considered inside the loop, and each indented line is executed once for every value in the list. So for example, this is a magician list. We can write for loop from the for magician in magicians, then these two lines indented considered inside the for loop. So we can write print magician's title form. That was a great trick. And print I can't wait to see your next trick. Then magician's title name, then a new line. Then after this for loop finished, then we can print a single message. But this statement not considered inside the loop. So any lines of code after the loop that are not indented are executed for once without repetition. We create a magician's list again. Then a for loop with two print lines included in the for loop. Run this. So for each element, each magician in list, we share two messages. So Alice, that was a great trick. I can't wait to see your next trick, Alice. And David, that was a great trick. I can't wait to see your next trick, David, and so on. Then after the for loop has been finished to run, then we can print one message. So this message, this print statement is not considered in the for loop, so print only once. Lists are ideal for storing sets of numbers, and Python provides a number of tools to help you work efficiently with lists of numbers. So we can use the range function. Python's range function makes it easy to generate a series of numbers. For example, you can use the range function to print a series of numbers like this. You can write a for loop, the for value in range 1 to 5. You can print a value. The result will print 1, 2, 3, 4. The range 1 to 5 will print a number from 1 to 4. Then for each value of this 1 to 4 will print out. So although this code looks like it should print the numbers from 1 to 5, it doesn't print the number 5. So in this example, range prints only the numbers 1 through 4. This is the result of off by 1 behavior you will see often in Python and many other programming languages. So if you want to print the numbers from 1 to 5, you would use range 1, 6. So for value in range 1, 6, print value. Can print out for value in range 1 to 5, print value. So 1, 2, 3, 4 has been printed out. Use range to make a list of numbers. If you want to make a list of numbers, you can convert the results of range directly into a list using the list function. So for example, we can create a list called numbers, and the value is 1 to 5. Then next we can print numbers. We create a list called numbers. Then print these numbers. So it's a list 1 to 5. And we can also use the range function to tell Python to skip numbers in a given range. For example, it is how we would list the even numbers between 1 and 10. We can write even numbers is a list, create is a list, and the value is from 2 to 11, not including 11, and with a gap of 2. So the result will be 2, 4, 6, 8, 10. So even numbers is a list in the range 2 to 11 with a gap of 2. Then we print out this list. This list has 5 elements. And you can create almost any set of numbers you want to using the range function. For example, consider how you might make a list of the first 10 square numbers. So we start with empty list, then write a for loop. So for each value in the range 1 to 11, not including 11, then we write calculate the square of this value, then assign to square variable Then in the list of squares, we append this square, and so on. Then when the for loop is finished, we print out this squares list. So we start with an empty list called squares, then we tell Python to loop through each value from 1 to 10 using the range function. And inside the loop, the current value is raised to the second power and stored in the variable square. Then each new value of square is appended to the list squares. So start with the empty list called squares. The for loop for each value in the range 1 to 11, calculate the square of this value and append to the squares list. Then the loop finished, we can print out this list. So the value is 10 numbers, and each value is the square of the value in the range 1 to 11. And to write this code more concisely, you can omit the temporary variable square and append each new variable value directly to the list. So we can also start with a squares list, empty list, then write a for loop with only one statement. So for value in range 1 to 11, we can calculate this square of this value, then directly append to this squares list. Then the for loop finished, then print out this squares list. Start with empty list squares, then for loop for each value in the range 1 to 11, calculate the square of this value, then append to the squares list. Then print out this list. The result is the same with 10 numbers, and each of numbers is the square of each value in range 1 to 11. A list comprehension allows you to generate this same list in just one line of code. A list comprehension combines the for loop and the creation of new elements into one line, and automatically appends each new element. The following example builds the same list of square numbers you saw in previous lectures, but uses a list comprehension. So we can write squares is list, and inside the bracket we write value asterisk 2, then space, then it's like a for loop for value in range 1 to 11. Then we can print out this squares list. The list comprehension begins with a bracket and the descriptor name for the list, such as squares. Next, open a set of square brackets and define the expression for the values you want to store in the new list. In this example, the expression is value square of this value, which raises the value to the second power. Then write a for loop to generate the numbers you want to feed into the expression and close the square brackets. Notice that no colon is used at the end of the for statement in list comprehension. So we can create this list use list comprehension. Then print out this list. Okay, so 10 numbers, and each number is squares of each number in the range of 1 to 11. You can also work with a specific group of items in a list, which Python calls a slice. To make a slice, you specify the index of the first and the last elements you want to work with. As with the range function, Python stops one item before the second index you specify. So the following example involves a list of players on a team. So this is a list with 5 players, and we can print players bracket 0 to 3, then it will return the first 3 elements. So the code prints a slice of this list, which includes just the first 3 players. So players is a list with 5 players, then can print the first 3 players. And you can generate any subset of a list. For example, if you want the second, third, and fourth items in a list, you would start the slice at index 1 and end at index 4. So 4 not included. Then it will return the second, third, and fourth element. So from the index from 1 to 3. So the second, third, and fourth elements will be returned. So we print the second, third, and fourth elements. And if you omit the first index in a slice, Python automatically starts your slice at the beginning of this list. So if you just write column 4, then it will return the first 4 elements. So we return the first 4 elements with column 4. And a similar syntax works if you want a slice that includes the end of a list. For example, if you want all items from the third item through the last item, you can start with index 2 and omit the second index in the bracket. So we can just write players 2 column. Then it will return all items from the third item and through the end of the list. We print players 2 column return from the second to the last items in the list. The negative index returns an element a certain distance from the end of a list. So therefore, you can output any slice from the end of a list. So, for example, we can write players bracket -3 then column. Then it will return the last 3 players. So it will return the last 3 players with negative index. And the looping through a slice. You can also use a slice in a for loop if you want a loop through a subset of the elements in a list. In the next example, we loop through the first 3 players and print their names. For example, can write for player in players. The slice with column to 3, then from the first to the third element of this list. Then for each element of these 3 elements, we can print each element's title for. So players 5 elements, print. So here are the first 3 players on my team. Then we can use a for loop for the slice of a list. So the first 3 elements played. And copy a list. To copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index. So we just use a bracket and a column inside the bracket to copy all the elements of the list. Now this tells Python to make a slice that starts at the first item and ends with the last item, and producing a copy of the entire list. For example, imagine we have a list of our favorite foods and want to make a separate list of foods that a friend likes. This friend likes everything in our list so far, so we can create the list by copying ours. So this is my foods list, and we can also create a friend's foods list with using the bracket or column. So the list of my friend's foods have the same items of my foods list. So my foods list pizza, Faro, carrot cake. Then we can create my friends foods list. Then we print out. So my favorite foods are this one, these three. Then my friends favorite food lists. Also these three items lists. To prove that we actually have two separate lists, we will add a new food to each list and show that each list keeps track of the appropriate person's favorite foods. So in the My Foods list, we append cannoli, and in the My Friends Foods list, we append ice cream. Then we print out the C. The My Foods append a new food, and My Friends Foods also append a different foods. Then we print to see my favorite foods. So this one is appended to in the My Favorite Foods. And this one appended to the My Friend's Favorite Foods. So which means these two lists are independent, separate lists. If we had simply set My Friend's Foods equal to My Foods, we will not produce two separate lists. So for example, this is My Food list, and we just use equal. So my friend's foods list is equal to my foods list. Then we append two different items to each list, and in this form, if to connect to list, then append item in one list will also do for the other. We will see. So for example, my foods list, create first with three items. Then we just use equal to assign the same value to my friend's foods list. Then we append two items to these two lists. Then we print out my foods list again. Now you can see these two items have been appended in the My Foods list. We also print My Friend's Foods. Also, these two items have been added, which means if we use equal sign to assign My Foods to My Friend's Foods, they are just reference to the same object. They are not copy, not independent objects. So if you append one item in one of the two objects, and this will also happen for the other one. Sometimes we want to create a list of items that cannot change. Tuples allow you to do just that. Python refers to values that cannot change as immutable, and an immutable list is called a tuple. A tuple looks just like a list, except you use parentheses instead of square brackets. And once you define a tuple, you can access individual elements by using each item's index, just as you would for a list. For example, if we have a rectangle that should always be a certain size, we can ensure that its size doesn't change by putting the dimensions into a tuple. So we define the tuple dimensions using parentheses instead of square brackets. Then print each element in the tuple individually, using the same syntax we have been using to access elements in a list. So this is a tuple with two elements. We use parentheses to create a tuple. Then if we want to get the elements, first elements, we just can use this tuple with a bracket 0. This form is same as the list, and this can get the second elements of this tuple. We create a tuple. Then we print out the first element and print out the second element of this tuple. And let's see what happens if you try to change one of the items in the tuple. So if we set the first element to 250 and Python will raise an error. So we create this tuple first. Then we try to assign a new, change the value of one element. Then type error tuple object does not support item assignment. And the looping through all values in a tuple. You can loop over all the values in a tuple using a for loop, just as you did with a list. So this is a tuple. We can also use a for loop for dimension in dimensions, then print each element. Create a tuple. Then we print a message. And we print each element of the tuple using a for loop. So two elements printed out. So writing over a tuple, although you cannot modify a tuple, you can assign a new value to a variable that holds a tuple. So if we want to change our dimensions, we could redefine the entire tuple. So you can, this is original tuple. This is the new tuple we defined. So if you want to change the value, because you cannot change the element by element, so you can define the tuple again with the new value. You can define the entire tuple again with the new value you want. So we create this tuple again with the new value. Then we print out. Then using a for loop to print this tuple out. Conditional tests. At the heart of every if statement is an expression that can be evaluated as true or false, and is called a conditional test. Python uses the values true and false to decide whether the code in an if statement should be executed. So if a conditional test evaluates to true, Python executes the code following the if statement. If the test evaluates to false, Python ignores the code following the if statement. A simple example of conditional tests. The following example shows how if tests let you respond to special situations correctly. Imagine you have a list of cars and you want to print out the name of each car. Car names are proper names, so the names of most cars should be printed in title case. However, the value BMW should be printed in all uppercase. Following code loops through a list of car names and looks for the value BMW. Whenever the value is BMW, it is printed in uppercase instead of title case. So this is a car list with 4 cars inside, and we write a for loop. So for car in cars, if this car equals BMW, then we print out this car's uppercase. Else, so if the car is not BMW, we run statement inside the else, then print this car with the title for. So we create car list, then write a for loop to print each car's name either in title form or in uppercase. So if the car is BMW, then print out in uppercase. So you can see Audi, Subaru, Toyota all in title case, but BMW is in uppercase 4. So checking for equality. Most conditional tests compare the current value of a variable to a specific value of interest. The simplest conditional test checks whether the value of a variable is equal to the value of interest. So if the value is BMW, then we check car equals BMW, then get true. And if the value is Audi, if we check car if equals BMW, then we'll get false. So we assign the value BMW to car, then we use double equal to check if its value is BMW. you'll get the value result true. And if we assign the odd value to car, then we check again if the car's value is BMW, then you will get false. And ignoring case when checking for equality. The testing for equality is case sensitive in Python. For example, two values with different capitalization are not considered equal. If the car is Audi with title form, but we check car's value is Audi, we'll get a false. So if case matters, this behavior is advantageous. But if case doesn't matter and instead you just want to test the value of a variable, you can convert the variable's value to lowercase before doing the comparison. So we again assign the value Audi with a title form to car. Then we check the condition if the value is equal to Audi with lowercase, but before we run this equal sign double equal, we add car.lower to transform the car's case to lower before we do the condition test. Notice that the lower function doesn't change the value that was originally stored in car. So the car's case is still Audi. And this lower is just a temporary transform this value to lowercase to do conditional tests. So we see car's value is Audi with title form. Then we check its value equals to lowercase Audi to get false. And we set again, for example, car's value is Audi, but we use lower function before doing the conditional test to get a true now. The checking for inequality. So when you want to determine whether two values are not equal, you can combine an exclamation point and an equal sign. So this means not equal. So we will store a requested pizza topping in a variable and then print a message if the person did not order anchovies. So this is request a topping called mushroom, this value. So if request a topping not equal to anchovy, then we'll print holded anchovies. So request a topping is mushroom. So we check if this topping not equal to anchovy, we'll print holded anchovies. So this message printed out because this value is mushroom, and we test if this value not equal to anchovy. This test will get true. Will get true, then this statement will be run in the for loop, in the if statement. And the numerical comparisons. So testing numerical values is pretty straightforward. For example, the following code checks whether a person is 18 years old. So if the person is 18 years old, then you test numerically if the age equals 18. You get a true result. You can also test to see if two numbers are not equal. So for example, the following code prints a message if the given answer is not correct. So answer is 17. So we test if answer not equal to 42. Then we print a message. This is not the correct answer. Please try again. So age is 18. Then we test age. If age is 18 equals 18, the result is true. The answer is 17. Then we test if answer not equal to 42, then we show the message because answer is not equal to 42. The message is printed out. And the numerical comparisons, you can include various mathematical comparisons in your conditional statement as well, such as less than or equal to, greater than, and greater than or equal to. So age is 19, for example, we can run these tests. So each of the above mathematical comparisons can be used as part of an if statement, which can help you detect the exact conditions of interest. So age is 19. Then we can test if age less than 21. We can also run if age is less than or equal to 21, or if the age is larger than 21, we get false. If the age is larger than or equal to 21, we'll get the false. And you can use AND to check multiple conditions. To check whether two conditions are both true simultaneously, you can use the keyword AND to combine the two conditional tests. If each test passes, the overall expression evaluates to true. If either test fails, or if both tests fail, the expression evaluates to false. For example, you can check whether two people are both over 21 using the following tests. So these two people has age 22 and 18. We can test if this age larger than equal to 21, and this one also older than 21. The result will be false because one is not larger than or equal to 21. But if we change the second one to 22, then we test again, then it will be true because both are older than 21. To write concisely, you can also add parentheses here, so it will be more clear. So we assign to age to person, then test if both are older than 21, then it will be false. And we assign new value to 22 for the second person. Then we test again, then it will be true. And you can also use the keyword OR, allows you to check multiple conditions as well, but it passes when either or both of the individual tests passes. So an OR expression fails only when both individual tests fail. So let's consider two ages again, but this time we will look for only one person to be over 21. So these two persons, 21, 22, 18 years old, then we test if one of the person is older than 21, the result will be true. And if we assign the first person to 18 also, then we test again, then the result will be false because none of the two people are older than 21 now. So we set these two persons' age to 22, 18, then test if using auto test if one of the at least one is older than 21, get the result true. But if we set the first person also to 18 years old, then test again if at least one is older than 21, we'll get the false. And checking whether a value is in a list. So sometimes it's important to check whether a list contains a certain value before taking an action. So to find out whether a particular value is already in a list, you can use the keyword in. So let's consider some code you might write for a pizzeria. We will make a list of toppings a customer has requested for pizza, and then check whether certain toppings are in a list. So this is a requested topping with 3 elements, a list. Then we will run the conditional tests. Mushrooms in requested toppings. This is true because mushroom in. But if we run the pepperoni in requested toppings, we'll get false because this list does not contain pepperoni. The requested topping is a list called pizzeria. Then we run the conditional test. Mushroom in requested topping, get the true in results. If we run pepperoni in requested topping, the result is false. And you can also check whether a value is not in a list. So similarly, you might want to know if a value does not appear in a list. You can use the keyword not in this situation. For example, consider a list of users who are banned from commenting in a forum. You can check whether a user has been banned before allowing that person to submit a comment. So this is a list for the banned user with 3 people. So another user called Mary. So if user not in banned user will print user's title form, you can post a response if you wish. So because this Mary, user's value is Mary not in this list. So this conditional test will get the true. So this message will be printed out. So we create a list for the banned user, and we create a value. Object user is Mary. Then we run this conditional test. If she's not in banned user, then it's true because Mary is not in the banned user. So the print out message, Mary, you can post a response if you wish. A simple if statement. The simplest kind of if statement has one test and one action. We can write if, for example, the conditional test to do something. This is the typical form. So if the conditional test evaluates to true, Python executes the code following the if statement. If the test evaluates to false, Python ignores the code following the if statement. So let's say we have a variable representing a person's age, and we want to know if that person is old enough to vote. So the following code tests whether the person can vote. So assign 19 to this age variable. So this if test if age is older than 18, then the message you are old enough to vote will be printed out. And indentation plays the same role in if statement as it did in a for loop. So all indented lines after an if statement will be executed if the test passes, and the entire block of indented lines will be ignored if the test does not pass. So you can assign age is 19. We can test this. Because it's older than 18, so these two statements are run. So you can have as many lines of code as you want in block following the if statement. So let's add another line of output if the person is old enough to vote, so asking if the individual has registered to vote yet. So these two messages will be printed out. And if-else statement. And if-else block is similar to a simple if statement, but the else statement allows you to define an action or set of actions that are executed when a conditional test fails. So we will display the same message we had previously if the person is old enough to vote, but this time we will add a message for anyone who is not old enough to vote. So if we assign 17 to the age, then test if age is 18, is larger older than 18, we will print these two messages. But if this test fails, so we will run the else statement. So age is 17. Then we test if age is older than 18, then print this message. Else, if this test is fail, then we will print these two messages. So because age is 17, not older than 18, then these two messages are printed out. Sorry, you are too young to vote, and please register to vote as soon as you turn 18. And the if and else chain, often you will need to test more than 2 possible situations. And to evaluate this, you can use Python's if else syntax. Python executes only one block in an if-elif-else chain. It runs each conditional test in order until one passes. So when a test passes, the code following that test is executed and Python skips the rest of the tests. The following code tests for the age group of a person and then prints an admission price message. So for example, age is 12. Then we run if age is younger than 4, then print this message. But this message, if this is fail, then Python will test this conditional test. If it is younger than 18 but older than 4. If this passes, gets a true result, then this message will be run. Then the if test, then the statement after the if test will be run. So if both of these conditional tests fails, then Python will run this message. We see age is 12. We'll test using if, elif, and else. The admission is 5 now because 12 is not younger than 4. Then this gets false. Then Python will test the next. Next will be true because younger than 18. So the statement inside the elif will be run. Then Python will finish this if statement, if, elif, else statement. And you can omitting the else block. Python does not require an else block at the end of an if-elif chain. Sometimes an entire block is useful. Sometimes it is clearer to use an additional if statement that catches the specific condition of interest. So for example, age is 12 again, then we can run if conditional tests, then elif another one, then elif another one, then elif another one. So we do not use else here. We just use very specific conditional test for each age group. So we see age is 12. Then we use a multiple if, elif tests. So in this if-elif test, price has been assigned one of each value. Then next we print out this value. We see your admission cost is 5. So age 12 for this group, price 5, because not younger than 4 but younger than 18. And the else block is a catch-all statement. It matches any condition that wasn't matched by a specific if or elif test, and that can sometimes include invalid or even malicious data. So if you have a specific final condition you are testing for, consider using a final elif block and omit the else block. This is what we have seen in this code. You can do some interesting work when you combine lists and if statements. You can watch for special values that need to be treated differently than other values in the list. You can manage change conditions efficiently, such as the availability of certain items in a restaurant throughout a shift. You can also begin to prove that your code works as you expect it to in all possible situations. So checking for special items. So let's continue with the pizzeria example. The pizzeria displays a message whenever a topping is added to your pizza as it is being made. The code for this action can be written very efficiently by making a list of toppings the customer has requested and using a loop to announce each topping as it is added to the pizza. So this is a request a topping list with 3 items. Then we can write a for loop for request topping in request toppings. For each element of this list, then we print adding this request topping. So you can create a list called request toppings. Then you can write for loop. For each request topping in request toppings, print add this request topping. So it's very clear: add mushroom, add green peppers, add extra cheese. Then last one, outside of for loop will print a final message. The job finished. But what if the pizzeria runs out of green peppers, and if statement inside the for loop can handle this situation properly? So this is request topping, and in the for loop we can test using if statement. So if request topping equals green peppers, then a message, sorry, we are out of green peppers right now, will be printed out. Otherwise, if this test is a fail, which means if the request topping is not equal to green peppers, then the message adding this request topping will be printed out. So create a request topping again. Then this for loop. In the for loop, we use an if statement to test if it is a green pepper. So the message is like this. So adding mushroom, and for the green peppers, the message will be like, sorry, we are out of green peppers right now. And for the extra cheese will be printed like adding extra cheese. So this is the last message of the for loop. And checking that a list is not empty. Sometimes it's useful to check whether a list is empty before running a for loop. So as an example, let's check whether the list of request topping is empty before building the pizza. If the list is empty, we will prompt the user and make sure they want a plain pizza. If the list is not empty, we will build the pizza just as we did in the previous examples. So we first create an empty list to request toppings. So just next we will run if request toppings, which means if request topping has at least one element and not empty, then it will run the for loop. Else, if request topping is empty, we will run another loop, another message. So when the name of a list is used in an if statement, Python returns true if the list contains at least one item. An empty list will evaluate to true to this conditional test. So here we create an empty list for request topping. Then we will run if-else statement. So if request topping is not empty, we will run this for loop. But if it is empty, then this test will fail. Then we run the else statement. So the else statement is run in this case now. Using multiple lists. What if a customer actually wants French fries on their pizza? You can use the lists and if statement to make sure your input makes sense before you act on it. So let's watch out for unusual topping requests before we build a pizza. And the following example defines two lists. The first is a list of available toppings at the pizzeria, and the second is the list of toppings that the user has requested. And this time, each item in request toppings is checked against the list of available toppings before it's added to the pizza. So the code will look like this. Available toppings is a list created, and request toppings is another list which created for the request toppings from the customer. Then we will write a for loop. Then For each request topic in the request toppings, we will check if this request topping in these available toppings lists. So if these tests get true, then we print add this request topic. Otherwise, if this request topping item is not in available toppings list, then we will run another message. We ask customer, say, sorry, we don't have these toppings. So we run create two lists. One is available toppings and one is request toppings. Then we write a for loop for each request toppings. Then test if this one is in the available toppings. If it is true, then we print this message. If it is not true, then we run the else statement. So you can see the mushroom is in the available topping list. So we're adding mushrooms. The same for the extra cheese, but for the French fries in the request topping, the message, sorry, we don't have French fries, will be run out. A dictionary in Python is a collection of key-value pairs, so each key is connected to a value, and you can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary. In fact, you can use any object that you can create in Python as a value in a dictionary. In Python, a dictionary is wrapped in braces, with a series of key-value pairs inside the braces. So this is a dictionary with two key-value pairs, and the key is color and points, and the value is green and 5. Accessing values in a dictionary. To get the value associated with a key, give the name of the dictionary and then place the key inside a set of square brackets as shown here. So we can access the value of key color. So this will print out the value of color. And similarly, this will print out the value of points in this dictionary. So this dictionary with two key-value pairs, so we can get the points value of this dictionary and assign to new points. Next, we can print out these new points with a message. So alien 0 is a dictionary with two key-value pairs, and we can print out the value of this dictionary's color. Its color is green. And we can print out the value of points. Points is 5. We can create this dictionary again. And we can get out the value of points and assign to this variable called new points. Then we can print out a message using these new points. So you just earned 5 points. So you can add new key-value pairs to a dictionary. To add a new key-value pairs, you would give the name of the dictionary followed by the new key in square brackets along with the new value. So let's add 2 new pieces of information to the alien 0 dictionary. The alien's x and y coordinates. So this is original dictionary has 2 key-value pairs. Then we can add a new key-value pair called x position equals 0 and y position equals 25. So this is the dictionary with 2 key-value pairs. And print out this dictionary, 2 key-value pairs. Then we add another 2 key-value pairs. And we print out again. Now the dictionary has 4 key-value pairs, color, points, x position, and y position, and their values. Notice that the order of the key value pairs does not match the order in which we added them. So Python doesn't care about the order in which you store each key value pairs in a dictionary. It cares only about the connection between each key and its value. And you can start with an empty dictionary. It's sometimes convenient or even necessary to start with an empty dictionary and then add each new item to it. To start filling an empty dictionary, you can define a dictionary with an empty set of braces and then add each key value pairs on its own line. So we can start with an empty dictionary with 2 braces. Then we add 1 key value pairs using alien0, brackets color equals green, and points equals 5. So add these 2 key value pairs into this dictionary. We start with an empty dictionary. Then we add these 2 key value pairs into a dictionary. Then print out again. Now the dictionary has 2 key value pairs. Can modify values in a dictionary. To modify a value in a dictionary, give the name of the dictionary with the key in square brackets and then the new value you want associated with that key. So for example, consider an alien that changes from green to yellow as a game process progress. So we create a dictionary with only 1 key value pair, color is green. Then we can modify the value of this key color to yellow. So we create first key value pair green in this dictionary, and we print out the alien's color. The alien is green now. Then we modify the color to yellow in this dictionary. And we can print out again. The alien is now yellow now. And you can set dictionary with, for example, for x position, y position, and a speed medium. Can print original position for this alien x position. So position is 0 now, original. Then we can move the alien to the right. So if alien 0 speed is slow, x increment is 1. And else if speed is medium, then increment is 2, and else increment is 3. So because x speed is medium now, so the increment is 2. And we can also we can run this test first. So x increment will be assigned with a true value now. Then we can modify the position x position with current position plus x increment. So run this to modify the value of x position. So print new x position. Now we'll see new position 2 because have increment with true value to the x position. And we can also remove key value pairs. So when you no longer need a piece of information that is stored in a dictionary, you can use the del statement to completely remove a key value pair. All del needs is the name of the dictionary and the key that you want to remove. For example, let's remove the key points from the alien0 dictionary along with its value. So this is a dictionary with 2 key value pairs. Then we can remove the points, the key value pairs with the points. Use del alien0 points in brackets. So we can create these key value pairs dictionary first. 2 key. So print. So there are 2 key value pairs in this dictionary. Then we remove 1 key value pairs points has been removed. We show again this dictionary now has only color key value pair. Because a dictionary can contain large amounts of data, Python lets you loop through a dictionary. You can loop through all of a dictionary's key value pairs, through its keys, or through its values. So looping through all key value pairs, to do so, you could loop through the dictionary using a for loop to write a for loop for a dictionary. So let's consider a new dictionary designed to store information about a user on a website. The following dictionary will store one person's username, first name, and last name. So this is a dictionary called user, and will store username Fermi, first name Enrico, and the last name Fermi. Then we can write a for loop for key value in user this dictionary's items attribute. So this username items attribute will return the key value pairs. Then for each key value pair, we will print key its value and value its value. So you create names for the two variables that will hold the key and the value in each key value pair. You can choose any names you want for these two variables. So you can choose any name for these two variables. The second half of the for statement includes the name of the dictionary followed by the method items, which returns a list of key value pairs. The for loop then stores each of these pairs in the two variables provided. So we can create dictionary for the user. Then we can write a for loop, and in the user zeros items, then we print out this information. So all the key value pairs in this dictionary are printed out. The username value, first name value, last name value. Another example of looping through all key value pairs. So we look at a dictionary of a favorite programming language of a number of people. So favorite language is a dictionary. Then the key is people's name, and the value are favorite languages of those people. Then we can write for loop. We'll create two variables called name language for name language in these dictionaries items. Then we can print names title form, concatenate with a message, and then concatenate with languages title form. So favorite language is a dictionary. Then a for loop will print out information for each person's favorite language. So Yan's favorite language is Python, Sarah's favorite language is C, and so on. So looping through all the keys in a dictionary. So you can use the keys method. It's useful when you don't need to work with all of the values in a dictionary. So let's loop through the favorite language dictionary and print the names of everyone who took the poll. So this is the same dictionary as before. Then we can write also for name, create one variable called name in this dictionary's keys attribute. So then can print out each name's title form. So this is a dictionary. Then a for loop in dictionary's keys attribute. Then only the keys and the people's name are printed out. So looping through the keys is actually the default behavior when looping through a dictionary. So the following two codes would have exactly the same meaning. We can write for name in favorite languages. Do not add any methods after this dictionary. Or we can write for name in favorite languages dot keys. These two statements will get the same result. You can choose to use the keys method explicitly if it makes your code easier to read, or you can omit it if you wish. And you can access the value associated with each key you care about inside the loop by using the current keys. So let's print a message to a couple of friends about the languages they choose. So we will loop through the names in a dictionary as we did previously, but when a name matches one of our friends, we will display a message about their favorite language. So this is the code. So we create same dictionary as before. Then we have friends, a list, 2 people of our friends. Then write a large for loop for name in favorite language to keys. So this name represents each name in this dictionary. Then print this name's title form first. Next, we write an if conditional test. So if this name in friends is this list. So if one of these keys is in this list, then we will print another message, hi, the name is title form, and a message, I see your favorite language is your favorite language's value, which language is title form. So we show this. Create this dictionary first. Then we create another list called friends with 2 items. Next, write a for loop to print out each people in the favorite languages list first. Then, if this person matches in this list, then we'll print another message for this friend. So first, Yang print out, then Sarah print out. Because Sarah is in the friend list, then Sarah will have another message printed out. Then Edward print out. Then Phil, because Phil also in the friend list, then Phil will also have another message printed out. And you can also use the keys method to find out if a particular person was pulled. So this time, let's find out if Erin took the pull. Same dictionary we produce. Then if Erin not in favorite language keys, we use not in. So favorite language.keys will return a list of these keys in the dictionary. The Erin if not in, so print Erin, please take your pull. And the keys method isn't just for looping, it actually returns a list of all keys, and the line simply checks if Erin is in this list. Because she is not, a message is printed inviting her to take the pull. We can create this dictionary first. Then check if Erin not in this dictionary's keys list, we'll print a message. Because Erin is not in, so the message is printed out. You can also loop through a dictionary's keys in order. So one way to return items in a certain order is to sort the keys as they are returned in a for loop. You can use the sorted function to get a copy of the keys in order. So create this list. Then we use naming sorted favorite languages keys and print out. Then choose this one, then create this first dictionary. Then we just sorted this list first before we choose each item in this list. Then print message for the name, title, thank you. You can see. So now the names are sorted in alphabetical order. and looping through all values in dictionary. If you are primarily interested in the values that the dictionary contains, you can use values method to return a list of values without any keys. For example, say we can loop and print out a programming language pool without the name of the person who chose each language. So this is the same dictionary. Then we can print a message following language has been mentioned. Then write a for loop. In this time, we use the values method for this dictionary, and then for language, the values method will get all values parts in the dictionary. Then we print out these old languages title for. So create this list, the dictionary first, then print a message. Then we use a for loop to print out all languages in this list. Sometimes you want to store a set of dictionaries in a list, or a list of items as a value in a dictionary. This is called nesting. You can nest a set of dictionaries inside a list of items inside a dictionary, or even a dictionary inside another dictionary. So first, look at a list of dictionaries. In the last lecture, the Alien Zero dictionary contains a variety of information about one alien, but it has no room to store information about a second alien, so much less a screen full of aliens. How can you manage a fleet of aliens? One way is to make a list of aliens in which each alien is a dictionary of information about that alien. For example, the following code builds a list of 3 aliens. So we create 3 aliens with different information, for example, different colors. Then we can store these 3 aliens in a list called aliens. Then next, we can write a for loop for alien in aliens, print out each alien. Actually, each alien is a dictionary's information with key value pairs. A more realistic example will involve more than 3 aliens with code that automatically generates each alien. So in the following example, we also can use range to create a fleet of 30 aliens. So we can start with an empty list. Then next, use a for loop. For loop in the range from 0 to 30. For each alien number, we create each alien, new alien. Then append this new alien in the aliens list. Actually, each alien's information is the same. So next, we can show the first 5 aliens in this alien list. Print out. We should create 3 aliens first. Each one a dictionary. Then we can put these 3 aliens in a list. Then next, using a for loop for alien in aliens, print out each alien. So each alien is a list printed out. The next, we make an empty list first. Then we create 30 aliens and put them in this list. Then we can print out the first 5 aliens in this aliens list. Actually have the same values, key value pairs for these 5. And we can also print the length of aliens, how many aliens in this list. So the total number of aliens is 30. So these aliens all have the same characteristics, but Python considers each one a separate object, which allows us to modify each alien individually. So imagine that one aspect of a game has some aliens changing color and moving faster as the game progresses. For example, to change the first 3 aliens to yellow, median speed aliens was 10 points each. We can do this. We write a for loop for the first 3 alien in this list. Then the if test, if alien's color is green, then we change it to yellow and change the speed to medium and change the alien's point to 10. So we can set alien's color speed points to this value if alien's color is green in the first 3 aliens. So next, let's look at a list in a dictionary situation. So it is sometimes useful to put a list inside a dictionary. For example, consider how you might describe a pizza that someone is ordering. If you were to use only a list, all you could really store is a list of the pizza's toppings. So with a dictionary, a list of toppings can be just one aspect of the pizza you are describing. So in the following example, 2 kinds of information are stored for each pizza: a type of crust and a list of toppings. So the list of toppings is a value associated with the key toppings. To use the items in the list, we give the name of the dictionary and the key toppings as we would any value in the dictionary. Instead of returning a single value, we get a list of toppings. So we make a pizza dictionary. Then inside this dictionary has 2 keys called crust and toppings. So for the crust, there only one value is 6. But for the toppings, is a list of values. Next, we can print out information. You order the pizza's crust. You put this type of pizza with the following toppings. Then inside the toppings, print each topping. So we create a dictionary, pizza, and with 2 keys, especially for the toppings, the keys is a list. Then we can print out information. You order the pizza. Which kind of pizza? The crust, thick pizza. You order the thick crust pizza with the following toppings. Then a loop for topping in pizza toppings. So pizza toppings will get this list because this list is the value of the key toppings. Then this is a list of with 2 elements. Then a for loop for topping in this list can print out each topping. So each topping are printed out. You can nest a list inside a dictionary anytime you want more than one value to be associated with a single key in a dictionary. So in the earlier example of favorite programming languages, if we were to store each person's response in a list, people could choose more than one favorite language. So when we loop through the dictionary, the value associated with each person would be a list of languages rather than a single language. So for the programming languages dictionary, in this time we use list to store the value for the languages each person like. For example, Phil, there are 2 programming languages, and Jan also 2 programming languages, but for Sarah only 1 programming language. Next, we can write a for loop for name language in favorite languages item. The item method will get a key value pairs. So key is the name, language is the value of this person. Then we can print name, the titles forms, favorite languages are. Next, inside the for loop, we'll write another for loop because this is a list. So we can write a for loop for language in languages. So languages is a list here. key value pairs, the value for this key, for example, is a list. Next, we can write a for loop for the value for each item in this list, then print out each language. We create favorite languages dictionary with value as list. Then for each people, we will print out his favorite languages. So this is the result. Jan's favorite languages are Python, Ruby. Sarah's favorite languages are C, so on. And the last case is dictionary in a dictionary. So you can nest a dictionary inside another dictionary, but your code can get very complicated quickly when you do this. For example, if you have several users for a website, each with a unique username, you can use the usernames as the keys in a dictionary. You can then store information about each user by using a dictionary as the value associated with their username. So in the following listing, we store 3 pieces of information about each user: their first name, last name, and the location. We will access this information by looping through the usernames and the dictionary of information associated with each username. We create a dictionary. So inside this dictionary, for the key Einstein is a person, then we store another dictionary as the value of Einstein, this key. And for Marie Curie, we store another dictionary as the value of this person. Next, inside, and for each dictionary of the value, there's 3 information for the first name, last name, and the location for this person. Next, we can write a for loop. For loop, first use the items method for the users. User is a dictionary, main dictionary. Then items will get the list of username and the user info pair. Then print a message. Then we create a variable called full name is user info. User info is a dictionary. User info's first name plus username info's last name concatenated with a space. Then location is user info's location's value. Next, we can print message with full name and location, title form. So create a dictionary with 2 scientists as the key and dictionary including first name, last name, and location as this person's value. Next, run a for loop which extracts the information of the key is the username and the user info is the dictionary from user's items method. Then print out information of username, then create a full name with the concatenation of the user info's first name and the last name, as well as the location information, then print out. So the result is username Einstein, then full name Albert Einstein, location Princeton, and similarly for username Marie Curie. In this lecture, you will learn how to accept user input in Python, so your program can then work with it. When your program needs a name, you will be able to prompt the user for a name. When your program needs a list of names, you will be able to prompt the user for a series of names. To do this, you will use the input function. How the input function works? The input function pauses your program and waits for the user to enter some text. Once Python receives the user's input, it will store it in a variable to make it convenient for you to work with. For example, we can use input function, and this is a prompt to the user. User will see this prompt. So tell me something and I will repeat it back to you. Then, after user has input the text of something, then this will store in the message variable. Next, we can print out this message. For example, we can try this. The user will see this, tell me something, and I will repeat it back to you. I try, for example, hello everyone. Then this information has been stored in the message. Next, we can print out this message. Hello everyone. So the input function takes one argument, the prompt or instructions that we want to display to the user so they know what to do. In this example, when Python runs the first line, the user sees the prompt, tell me something, and I will repeat it back to you. The program waits while the user enters their response and continues after the user presses enter. And the response is stored in the variable message. Then print message displays the input back to the user. And when you run input in Spider, sometimes comes with internal problem with this function. One way to solve this problem is to upgrade the Spider to version 5.3.0 using command and Anaconda prompt. So you can start Anaconda prompt in Windows Start menu, activate your environment. You have create an environment called NumPy, for example. Then you activate this NumPy environment, use conda activate NumPy. Then you can install Spider with the version 5.3.0 using this command pip install spider equals 0 double equal. After it is successfully finished, then check if the version of Spider is 5.3.0. You can use conda list Spider will show this information. Then you start Spider from Windows. You start menu Anaconda. So writing clear prompts. Each time you use the input information, you should include a clear, easy-to-follow prompt that tells the user exactly what kind of information you are looking for. Any statement that tells the user what to enter should work. For example, add a space at the end of your prompt after the colon in the preceding example to separate the prompt from the user's response and to make it clear to your user where to enter their text. So for example, you can set the prompt to input as please enter your name, and here with a space. Try. And build a multi-line string for the prompt. Sometimes you will want to write a prompt that's longer than one line. For example, you can store your prompt in a variable and pass that variable to the input function. This allows you to build your prompt over several lines, then write a clean input statement. For example, we can store prompt first with this message. If you tell us who you are, we can personalize the messages you see. Then we can use plus equal to add a new line with another information to this prompt variable. So next we can use input function and passing this prompt. So user will see if you tell us what you are, what's your first name, 2 lines information prompt. So we create prompt this line first. Then we add another line to this prompt. Then we use input and with this prompt to the user. So user will see 2 lines for the prompt. Try a name, Wilson. Then next we can print out this name. Hello Wilson. Using int to accept numerical input. So when you use the input function and the user inputs a number, Python interprets it as a string. If all you want to do is print the input, this works well, but if you try to use input as a number, you have to use the int function, which tells Python to treat the input as a numerical value. The int function converts a string representation of a number to a numerical representation as shown here. So user will see this prompt, how old are you? So if, for example, if he inputs 21, then the age will store this 21, but this value is a string. So next, you can use int function to change this string value to a numerical variable. Then we can use some numerical comparison. For example, if his age is older than 18. We try it. How old are you in inches? "25", for example. Then we store this height variable and change to int form. Use int function. So now height can be used to do some numerical comparison. For example, if height is larger than 36, print this message. If not, then print else message. So you will be able to write when you are a little older. Yeah, this is the code what we have used. The modulo operator. A useful tool for working with numerical information is the modulo operator, which divides one number by another number and then returns the remainder. So we use the percent symbol for the modulo operation. For example, 4 modulo 3 will get 1, and 5 modulo 3 will get 2 here. Get 2 here. The following program will tell the input value is even or odd using modulo operation. So user will input something according to this prompt, enter number, and I will tell you if it's even or odd. Then use int function to change this number as a numerical variable. Then we can use an if statement test to test if the number is modulo 2 will be 0. If modulo 2 0, then this number is an even number. Will print is even information. If not, then this number is odd number. So first we'll accept a user input. For example, input 19. Then use int function to set number as numerical value. Then we can run this if-else statement. So the number 19 is odd. The for loop takes a collection of items and executes a block of code once for each item in the collection. In contrast, the while loop runs as long as or while a certain condition is true. You can use a while loop to count up through a series of numbers. For example, the following while loop counts from 1 to 5. We set current number to the first initially. Then we do a while loop, check if current number less than or equal to 5, then print this current number. Then inside this while loop, we also increase this current number with 1. Then it will go back, check again if this condition still true. So and so on until run the current number if not less than or equal to 5, then the while loop stops. So in the first line, we start counting from 1 by setting the value of current number to 1, and the while loop is then set to keep running as long as the value of current number is less than or equal to 5. The code inside the loop brings the value of current number and then adds 1 to that value with current number equals 1. And this operator is shorthand for current number equals current number plus 1. So Python repeats the loop as long as the condition current number less than equal to 5 is true. We show current number with 1, assigned with 1 first. So while loop, while this condition is true, will print out this number and then increase this number with 1. So this 5 number is being printed out. So letting the user choose when to quit. So in the following program, we define a while loop. We then define a quit value and then keep the program running as long as the user has not entered the quit value. So prompt, we create prompt value message, the 2 line, tell me something and I will repeat it back to you. Then enter quit to end the program. So we start with an empty string called message. Then our message is not quit, is not equal to quit. If this is true, then we will let user to input some message with this prompt. Next, then print message. So this while loop will run until user input quit. So if user do not input quit, this while loop will always run forever to end to print the message you have input. But if you input quit, then while loop will stop immediately. So we create this prompt variable, then create empty message, then run this while loop and let the user to input this message and print out this message. Try hello. So print out hello has been printed out. Okay. Everyone print out. So now we input a quit. So quit print out and while loop stopped. This program works well, except that it prints the word quit as if it were an actual message. So actually quit is not the message you wanted to be printed out. The simple if test fixes this. This is same 2-line prompt and same for start with an empty message. Then inside the while loop, we can get the input from the user. Then we will test if this message not equal to quit, then we can print this message. So if this message is quit, we will not print out this message. So we can try this. This is the same as before. Then the while loop has been changed with adding an if statement. If the message is not quit, then we print out this message. Then hello. Then hello is printed out. Everyone printed out. But we input a quit, message not printed out, and while loop also stopped. Using a flag. So in the previous example, we had the program perform certain tasks while a given condition was true. But what about more complicated programs in which many different events could cause the program to stop running? So if many possible events might occur to stop the program, trying to test all these conditions in one while statement becomes complicated and difficult. So for programs that should run only as long as many conditions are true, you can define one variable that determines whether or not the entire program is active. This variable, called a flag, acts as a signal to the program. So we can write our program so they run while the flag is set to true, and stop running while any of several events sets the value of the flag to false. So let's add a flag to the previous program. This flag, which we will call active, so you can call it anything, will monitor whether or not the program should continue running. So we set create to their message, prompt message. Then we create a variable called active is true. Next, we will run a while loop. Start with while active. So while active means if the active's value is true, then while active will be true. If the active's value is not true, so while active will not be true. So the while loop starts with while active. So the message, user will input a message. So if the message equals quit, then we'll set active to false. If the message is not quit, then we will print this message, then run while loop again. Until user input quit, we will set active to false, then while loop will stop. We create this prompt message, then set a flag variable active to true first. Then run a while loop. While active, then user can input a message and Python will check if the message is quit. If quit, then while loop stopped, and active, because active set to false, then the loop will stop. If it is not quit, then we'll print out this message and back to the while loop check again. So we run. Hello, everyone, then quit is stopped, while loop stopped. Using break to exit a loop. To exit a while loop immediately without running any remaining code in the loop. So regardless of the results of any conditional test, you can use the break statement. The break statement directs the flow of your program. You can use it to control which lines of code are executed and which aren't. So the program only executes code that you want it to when you want it to. For example, consider a program that asks the user about places they have visited. So we can stop the while loop in this program by calling break as soon as the user enters the quit value. So this is 2 lines message. Prompt the user to tell a city they have visited and can enter quit if they are finished. So a while loop with while true start. So while true is always true if nothing else happened. So while true is always true. Then prompt the user to input a city. So next is if test. If the city is quit, then break. Then while loop stopped. If the city is not quit, then a message I'd love to go to this city are printed out. The loop that starts with while true will run forever unless it reaches a break statement. You can use the break statement in any of Python's loop. For example, you could use break to quit a for loop also, that's working through a list or a dictionary. So we'll show this code. First, create this prompt message variable. Then we will run this while loop. So user will see this prompt, enter city to New York. Then the message I'd love to go to New York printed out. Next I will input London. Then I'd love to go to London. Then here now I have put input quit. So the while loop stopped. And you can also use continue in a loop. So rather than breaking out of a loop entirely without executing the rest of its code, you can use a continue statement to return to the beginning of the loop based on the result of our conditional tests. So for example, consider a loop that counts from 1 to 10 but prints only the odd numbers in that range. So we create the first value of current number is 0. Then we run a while loop for the test if current number is less than 10. So at the beginning it is true because 0 less than 10. So run the while loop. Inside the loop, first we add 1 to this number. Then we if test if this number modulo 2 equals 0, which means it is an even number, then it will continue. So continue will go back to the while loop, and without running the rest of code in the while loop, but not stop this while loop. Just skip the rest of the code and back to the while loop. So if it is an even number, we do nothing, just back to the while loop. But if it is not even number, it's an odd number, then we print this number and back to the while loop also. So first we set the current number to 0 because it's less than 10. Python enters the while loop. So once inside the loop, we increment the count by 1. So current number is 1. And the if statement then checks the modulo of current number and 2. If the modulo is 0, which means current number is divided by 2, the continue statement tells Python to ignore the rest of the loop and return to the beginning. So if the current number is not divisible by 2, the rest of the loop is executed and Python prints the current number and back to the while loop again. So we will show current number is 0. Then a while loop will print out only odd number. So only odd number 1, 3, 5, 7, 9 are printed out, and the even number not printed out, and the code using continue. So you will not stop the while loop, just skip the rest of the code in this run. To keep a track of many users and pieces of information, we will need to use lists and dictionaries with our while loops. A for loop is effective for looping through a list, but you shouldn't modify a list inside a for loop because Python will have trouble keeping track of the items in the list. To modify a list as you work through it, use a while loop. Using while loops with lists and dictionaries allows you to collect, store, and organize lots of inputs to examine and report on later. So we can move items from one list to another. So consider a list of newly registered but unverified users of our website. After we verify these users, how can we move them to a separate list of confirmed users? One way would be to use a while loop to pull users from the list of unconfirmed users as we verify them, and then add them to a separate list of confirmed users. So this is a list of unconfirmed users. Then we create an empty list called confirmed users. The next use a while loop. So while loop, the purpose of this while loop is to move each unconfirmed users to verify and then to confirm the users list. So while unconfirmed users means if unconfirmed users list is not empty, there are users in this list, then we will run the while loop. So we use a pop function to take the last one of this list, last item of this list out, then store in a current user. Then we print a verifying message. Then in confirmed users list, we append this current user. So this process will run until there are no items left in unconfirmed users. Then next, we can write a for loop to print out each confirmed users from this confirm the user's list. So we set unconfirmed users list first. Then create confirmed user list with empty. So run a while loop to move every unconfirmed user out, verifying them, and put in confirmed users list. So verifying user, each being done. Then we print following users have been confirmed. Then for loop for the confirmed users list, each item will be printed out. And you can remove all instances of specific values from a list. The remove function will remove the instance that appeared only once in the list. But what if you want to remove all instances of a value from a list? Say you have a list of pets with the value cat repeated several times. To remove all instances of that value, you can run a while loop until cat is no longer in the list. So this is a list with pets. The cat occurs 3 times here. Then we can write a while loop. So while cat in pets, then we will remove cat. So while cat in cat means while cat exists in this list, it still have cats list exists in this list, then we'll remove this cat. So until there are no cat in these pets, then the while loop will be finished. So we create these pet lists and print cat, cat, cat. Then a while loop will remove each one cat in the list, and we print pets again. There are no cats now in the list. So filling a dictionary with user input. So you can prompt for as much input as you need in each pass through a while loop. So let's make a pooling program in which each pass through the loop prompts for the participant's name and the response. We can store the data we gather in a dictionary. So first, we create an empty dictionary, then set a pooling active flag to true. So while pooling active, then user will see prompt what is your name. Then the response is input and user input name to name variable. Similarly, user will input the mountains information for the response variable. Then for the dictionary, this dictionary created here, we add key value pairs for name, the person, and its response, the value of this mountain. Then repeat is another input for user to enter. The prompt is would you like to let another person respond? So if the user does not enter no, then process will be continue, and the user can do back to the while loop, and the user can input again the name and the information for the response with mountains, then add another key value pairs in dictionary. So this process will until user enter no in the repeat input. If the user enter repeat input with no, then pooling active flag will be false. So back to the while loop, pooling active will not be successful, then the while loop is stopped. So next, then we can print out information from this dictionary with the function items and get name response pairs, each name response pairs, and print it out in this message. So we set this empty dictionary first, then while loop, in the while loop user will enter name and response of the mountain, and while loop will set key value pairs in this dictionary. Then user will see another prompt. Would you like to let another person respond? If the user does not enter no or enter yes or other input, then the while loop will continue on, and user then enter another name and mountain, and so on until user has entered no here. Then the key pooling active flag will be false. Then the while loop will be stopped. So we run this process. Okay, we have to define pooling active first. Then what's your name? Wilson. Himalaya is mountain. Would you like to let another person respond? Yes. What's your name? Shirley. What the mountain would you like to climb someday? Kilimanjaro. Would you like to let another person to respond? This time enter no. So the while loop stopped. Then we print out the results. Pulling results, and for name items, a for loop to get out all the key value pairs in this dictionary, and print out all information. Wilson would like to climb Himalaya, and Shirley would like to climb Kilimanjaro. In this lecture, you will learn to write functions, which are named blocks of code that are designed to do one specific job. So when you want to perform a particular task that you have defined in a function, you call the name of the function responsible for it. If you need to perform that task multiple times throughout your program, you don't need to type all the code for the same task again and again. You just call a function dedicated to handling that task, and the call tells Python to run the code inside the function. So we define a simple function. Here's a simple function named greet user that prints a greet message. So use diff greet user. Then this is the description of this function. Use triple quotes. Then inside the function, print a message hello. Then we can call this function just write greet user. The keyword diff to inform Python that you are defining a function. Then next name of the function is greet user. Then parentheses are empty here, means no more information needed to run this function. And a comment called a docstring enclosed in triple quotes, which describes what the function does. The docstrings are enclosed in triple quotes. Greet users call the function. So we define a function called greet user, and inside the function print hello message. Then we'll call this function just print greet user and parentheses. The function greet user can not only tell the user hello, but also greet them by name. So for the function to do this, you enter username in the parentheses of the function's definition at the diff greet user. So by adding username here, you allow the function to accept any value of username you specify. So if we want to print message with different username, so we can put a parameter here in the definition of function in the parentheses. So inside the function, print message will take this information of username and print a message. So when we call this function, we have to add a name, for example, Jesse here. So the variable username in the definition of greet user is an example of a parameter, a piece of information the function needs to do its job. And the value Jesse in greet user Jesse is an example of an argument. An argument is a piece of information that is passed from a function call to a function. So when we call the function, we place the value we want the function to work with in parentheses. In this case, the argument Jessie was passed to the function greetUser, and the value was stored in a parameter username. Note that people sometimes speak of arguments and parameters interchangeably. So we create again this function greetUser with the username as a parameter. Then we can print out a message using this username. The function defined. Then we call this function and adding a Jessie here in the parentheses. So the message "Hello Jessie" is printed out. Because a function definition can have multiple parameters, a function call may need multiple arguments. You can pass arguments to your functions in a number of ways. You can use positional arguments, which need to be in the same order the parameters were written. Keyword arguments, where each argument consists of a variable name and a value, and the lists and dictionaries of values. So positional arguments. When you call a function, Python must match each argument in the function call with a parameter in the function definition. The simplest way to do this is based on the order of the arguments provided. So values matched up this way are called positional arguments. To see how this works, consider a function that displays information about pets. The function tells us what kind of animal each pet is and the pet's name. We define a function called DescribePet with two parameters needed to run this function. First is animal type, second is pet name. Then in the function definition, we print a new line, then a message "I have this type, animal's type." Then print another line, this animal type's name is this pet name's title form. So when you call this function, you have to write DescribePet, then the type first, then name second. Or you can run again, call the dog is the type, then Willy is the name. So we define this function first. Then we call this function. Then I have a hamster. My hamster's name is Harry. We call again with this information input. I have a dog. My dog's name is Willy. So order matters in positional arguments. You can get unexpected results if you mix up the order of the arguments your function call when using positional arguments. So for example, if you call this function but write this order, Harry hamster, so this will print the message "not you want." And a keyword arguments. A keyword argument is a name-value pair that you pass to a function. You directly associate the name and the value within the argument. So when you pass argument to the function, there is no confusion. Keyword arguments free you from having to worry about correctly ordering your arguments in function call. So let's rewrite the pets examples using keyword arguments to call DescribePets. So we can also call this function. Then in the parentheses we write key value. So you can write any order if you input the key value pairs. And we can also call a pet name right first, Harry, and animal type second. It's correct. So the order of keyword arguments doesn't matter because we explicitly tell Python which parameter each argument should be matched with. So we call using keyword arguments. So I have a hamster. My hamster's name is Harry. Then call again with this keyword order So I have a hamster, my hamster's name is Harry. The return result is the same. And default values. So when writing a function, you can define a default value for each parameter. If an argument for a parameter is provided in a function call, Python uses the argument value. If not, it uses the parameter's default value. For example, if you notice that most of the calls to describe a pet are being used to describe dogs, so you can set the default value of animal type to dog. Now anyone calling describe pet for a dog can omit that information. We can define this function with pet name, but animal type we set a default value as dog. So when you print, when you call this function, if it is a dog, you can just input the name of this pet. You need not input a dog, but the function definition with the default value have to be put after the argument parameter without default name, without default value. So dog, because the default value for animal type is dog, so we have to put this parameter in the end in the function definition. So when we call this function, we can also write pet name Willy. So in both calling without animal type in the input, so the function will assume that animal type is dog. So we create this function with the default value with dog for the animal type. Then call this. So I have a dog, my dog's name is Willy. So this information is for name. And I call again. I have a dog, my dog's name is Willy. To get the same result. Note that the order of the parameters in the function definition had to be changed because the default value makes it unnecessary to specify a type of animal as an argument. So the only argument left in the function call is the pet's name. So Python still interprets this as a positional argument. So if the function is called with just a pet's name, such argument will match up with the first parameter listed in the function's definition. So this is the reason the first parameter needs to be pet name. And the simplest way to use this function now is to provide just a dog's name in the function call. And to describe an animal other than dog, you could use a function call like this. So if we describe a pet, but the pet is not a dog, so we have to input pet name is Harry and animal type is hamster. Because the position arguments, keyword arguments, and default values call can be used together, often you will have several equivalent ways to call a function. For example, we will have a dog, the name is Willy, so we can describe a pet, Willy, which we have seen, and describe a pet name is Willy, these two we have run. And if a hamster name is Harry, we can write Harry here, hamster second, because this is in the definition is the second place for the type, but with a default value because the hamster is not dog, so we have to input hamster here. But you can also write pet name is Harry, animal type is hamster. This is very clear. And because we use keyword and value type, so we can also write animal type first, hamster, then pet name Harry second. No problem. This it works correctly. So we will try this equivalent calls. So these two we have run. I have a dog, my name is Willy. Then if I have a hamster named Harry, I can run this first. Then can run this calling. We get the same result. My hamster's name is Harry. And this one also correct. My hamster's name is Harry. Return values. A function doesn't always have to display its output directly. Instead, it can process some data and then return a value or set of values. The value the function returns is called a return value. The return statement takes a value from inside the function and sends it back to the line that called the function. So returning a simple value. Let's look at a function that takes a first and a last name and returns a neatly formatted full name. So this is a function definition. Get formatted names with two parameters, first name and the last name. Then inside the function, a full name variable is created with a concatenation of first name, space, and the last name. Then a return statement return full name's title form. So when we call this function get formatted name with input information for first name and the last name, then the return value of this full name's title form will be saved back to musician. Then next we can print this musician. We create this function and call this function and store return value full name to musician. Then we print out this musician, Jimi Hendrix, exactly same as what we have inputted. So making an argument optional. Sometimes it makes sense to make an argument optional so that people using the function can choose to provide extra information only if they want to. You can use default values to make an argument optional. For example, say we want to expand get formatted name to handle middle names as well. The first attempt to include middle names might look like this. So we need middle name in this function. So normally people may write like this: first name, middle name, last name in as the parameters. Then inside the function definition, a full name is concatenated from first name, space, middle name, space, and the last name. Then return this full name's title form. When people call this function, just write get formatted name with first, middle name, and last name. So we try this function definition and call this function with first name, middle name, and the last name. Is a positional argument. Passing position argument. So then after calling this function, the musician will get the value of this returned value full name. Then we print this musician. So first name John Hooker Lee printed out. This function works when given a first, middle, and a last name. The function takes in all three parts of a name and then builds a string out of them. But middle names aren't always needed, and this function as written would not work if you try to call it with only a first name and a last name. So this function does not work when people have not middle name to input. The better solution would be to make middle name optional. So we can give the middle name argument an empty default value and ignore the argument unless the user provides a value. So this is a better solution for definition of this function. So inside the parenthesis position, we write first name, last name, then middle name at the last with a default value of empty string. Then inside the function, we use if-else test. So if middle name means if the middle name is not empty, which means if user inputs some middle name, then the full name is the concatenation of these three names together. Else means if user did not input a middle name, so full name is only first name concatenated with last name. Then in the end, function will return full name, the title form. So when we call this function, no matter whether the people has middle name or not middle name, this function works. So in this case, we call this function with only first name and last name. Then in this case, we can call function with first name, last name, and middle name. Just note middle name have to be put in the last place, because in the definition, first name, last name, then middle name. We create this function first with middle name as default, has a default empty string. Then we call this function with only first name and last name. Then we print so only first name, last name. And we call this function with first, last, and middle name input. Then print this musician. Now three name, first name, middle name, and last name. A function can return any kind of value you need it to, including more complicated data structures like lists and dictionaries. For example, the following function takes in parts of a name and returns a dictionary representing a person. We define a function called buildPerson. Information in parameters are first name, last name. So the person is a dictionary created in the function. And for this dictionary, there are two key value pairs. First is the first value is the first name from the parsing of this first name, and key last, the value is last name passed from these positions parameter. So then function return person, this dictionary, when you call this function. So next we call this function buildPerson, then with information for first name, last name passing. We create this function with a return a dictionary of a person. Then we call this function and with passing first name and the last name, and stored back to the musician. So the musician is a dictionary because this function returns a dictionary. So we print out this musician is a dictionary with first two key value pairs. Key first value is Jimmy, last is key, the value is Hendrix. And you can easily extend this function to accept optional values like a middle name, an age, an occupation, or any other information you want to store about a person. For example, the following change allows you to store a person's age as well. So we define a function called buildPerson, but this time we add another parameter called age with default value is empty string in addition to first name and the last name. So inside the function, we create a dictionary called person with two key value pairs, first and last first. Then we run a if test if age. So if age means if user inputs age when calling this function, then we create another key value pair for this person's dictionary. Then key is age and the value is the age user inputs. Then in the end we return this person dictionary. So when you call this function, you input Jamie Henrik's first name, last name, then you add a key value pair like age equals 27. Then the musician will be a dictionary include information with a key value pair for first name, last name, and age. We define this function with age as a default empty string value in addition to first name and the last name, and return this person if age is input with a value, then the person has key value pair for age also. Then we call this function, and the return person's dictionary will be stored in the musician with input Jamie Hendrix and age 27. Then we print out this musician. So now musician is a dictionary with 3 key value pairs: first name, last name, and age. Using a function with a while loop, you can use functions with all the Python structures you have learned about so far. For example, let's use the getFormatTheName function with a while loop to greet users more formally. It is the first attempt at greeting people using their first and last names. So you can define a function with 2 parameters, first name, last name. Then inside the function, create variable called full name with the concatenation of first name, space, and last name. Then return these full names title form. Then we write a while loop. So while true, it will be always true if nothing happens. So in the while loop, print message for the user to input a name, and if user input a Q, then it will be quit. Then the while loop will stop. Then next, create 2 variable called fName, get the information of the first name, the lName get information of last name user input. Then format the name, calling this getFormatTheName function, and store the return value of full name to format the name. Then print message including this formatted name. In the previous example, we use a simple version of getFormatTheName that doesn't involve middle name. And the while loop asks the user to enter their name, and we prompt for their first and last name separately. But there is one problem with this while loop. We haven't defined a quit condition, and the while loop will be run infinitely. We want the user to be able to quit as easily as possible, so each prompt should offer a way to quit. The break statement offers a straightforward way to exit the loop at either prompt. In the following example, we add a message that informs the user how to quit, and then we break out of the loop if the user enters the quit value at either prompt. So the program will continue greeting people until someone enters Q for either name. So we change the while loop here. After user see the input for the first name, after user input, there will be a if conditional test. So if user input Q for the first name, then it will be break, then the while loop will stop. So if the next for L last name input from the user also will be a if test. If this time user input Q, then also will be break. We try to use this. Create this function first, then we run a while loop which include Q if user input. So first name Wilson, last name Shirley, then hello Wilson Shelly, then first name James, last name Wilson, then print it out. Then we input Q and the while loop stopped. Passing a list to a function. You will often find it useful to pass a list to a function, whether it is a list of names, numbers, or more complex objects, such as dictionaries. When you pass a list to a function, the function gets direct access to the contents of the list. Say we have a list of users and want to print a greeting to each. The following example sends a list of names to a function called greetUsers, which greets each person in the list individually. So we define a function called greetUser with parameter called names, and the names is a list. So inside the function, there's a for loop for name in names. So get each element of this names list, then set it to variable name. Next, we create a message with the concatenation of hello and the names title for, then print this message. So when we call this function, we create a user names with 3 names in this list, then call this function greetUsers with passing this usernames list. We define this function first, then create a list called usernames, and call this function with passing this list. Then greeting message for each person in the list has been printed out. Hello Hannah, hello Chai, hello Margot. Modifying a list in a function. When you pass a list to a function, the function can modify the list. So any changes made to the list inside the function's body are permanent. Consider a company that creates 3D printed models of designs that the users submit. So designs that need to be printed are stored in a list, and after being printed, they are moved to a separate list. The following code does this without using function. So if we do not use a function, we will use the following codes. So we create a list called unprinted designs with 3 elements, then create a completed models with empty list first. Then we write a while loop. So while unprinted designs, if there's any element left in unprinted designs, then we pop out this element, the last element in this list, then set to current design. Then we print a message, so printing model, printing this current design now. Then we append this current design to this completed models list we created here. So when the while loop runs until unprinted design is empty, because we pop it out empty. So then the while loop are finished and all items have been moved from the unprinted design to the completed models. So next we can print out this information for each completed model in the completed models list. So we create these 2 lists, then use a while loop to move all items from unprinted design to completed models. So printing model, so each element has been printed. Then we print a message following having completed, then a for loop in this completed models list, print each model. Each model has been completed. So we can recognize this code by writing 2 functions, each of which does one specific job. The first function will handle printing the designs, and the second will summarize the prints that have been made. So we define the function print models with two parameters, a list of designs that need to be printed and a list of completed models. So given these two lists, the function simulates printing each design by printing the list of unprinted designs and filling up the list of completed models. Then define a function called showCompleteModels with one parameter, the list of completed models. So given this list, showCompleteModels function will display the name of each model that was printed. So this is the code. So we first define a function called printModels. So there are two parameters, unprinted designs and completed models. Both are lists. Then inside the function is a while loop, very similar to the while loop we see in the previous pages. Then the current design is the pop value from the unprinted designs if unprinted design is not empty. Then we print a message, we print this current design now. Then we append this current design to the completed models list. The next, another function called showCompleteModels with one list as parameter, completed models. So we print a message, then for completed models, each completed model in completed models list will print this model. So when we call this function, we first define two lists. One is unprinted designs with 3 elements. One is completed models with empty value, initial empty value.